Here we see the layout that we created earlier. If we go to the options menu, the very first option is edit mode, and we can use this to basically remove the editing controls from the interface. This makes it much cleaner when you're operating from this sort of panel. So if we go back into edit mode, you'll see now that the colours have changed in the background. For the background colour, we set the background colour with the set background colour command. I quite like the dark grey, it makes certain things show up quite well. There are all sorts of other colours, such as this rather vivid yellow. And the colours of track segments can be edited within the edit diagram by context menu on the track segment, and then usually the create edit block will bring up the relevant thing with the occupancy sensor, and in the little section below there we've got the track colour set to light grey and the occupied track colour still set to red. And we can see the occupancy sensor name, out sensor, matches that on the block, and if the sensor changes from active to inactive, the block colour changes from light grey to red. That's what we hoped. Now we're going to go on and open the table to create the signals. Signals, as we described in the text, are made of two components. There's a head, which defines the actual devices that change, such as the accessory decoder being used, and the mast. A mast is made of one or more heads depending on the type of signal. So we're going to start by defining the signal head for the bay platform. This is a 3 output decoder, so we pick a triple output decoder, and we're going to give it the accessory decoder address for the green output, which I know is 21, and then the decoder address for the yellow output, which is 22, and the address for the red output, which is 23. We give it a system name which starts IH for a signalling head. The system name is not too important, although try to keep them reasonably sensible, and the username, which is important. So this is going to be the bay signal head, or the bay head. So we do that, and it adds it to the table, and if we close the add signal dialog, we can see that we can change the state of the signal, and that will be changing the state on the accessory decoders. We'll see in the turnout table that it's added the accessory decoders and put comments in the fields as to where they came from. Now back in the heads, we can see it has some flashing states which are not actually correct for British signalling. However, the control of what states the head will get to are made by the mast, and we'll get onto a mast in a moment. So now let's add another signal. We're going to define the 3-aspect light which controls the signal controlling access into the bay platform from the down line. Now we're going to use a trick which is described in the text, where we can use a double output decoder to control a 3-aspect signal. This is a small change to wiring which has to be made. You need to read the text to understand how it's done. It does save you quite a bit on decoders. So we've got to define the green and the red output addresses. In this case they're 31 and 32. That's the addresses of the two decoder outputs we're using to drive this signal. Okay, in actual fact the green is 32 and the red is 31. Now, because of the way the wiring has worked for this signal, we'll actually find that clicking through the states won't be quite giving us the outputs we wanted. This is because we need to change a little trick in the turnout table and invert the output of the green signal. This is the final bit of the wiring trick to get us to control the 3-aspect signal from 2 decoders rather than 3 decoders. So we've inverted that output, go back to the head, and if we flick through the states we'll find the signal behaves correctly. Now, before we've completed our down approach signal, we need to add another head. This controls the call on light. This is just a simple lamp which goes on and off, so it's a single output, and we give it an internal system name. In this case we can call it IH34. The username is going to be the call on, and we're going to need to create the decoder address for it, which is 34, and we need to define its appearance. Now, the important appearance for a call-on signal, which is used in the mast behavior, is lunar, so we need to define the appearance as lunar. So we create that by clicking OK, and it's added to the table, and you can see it got lunar, flashing lunar and dark as the three states, and you'll find that causes the signal to go on or off or flash. Now into the masts. Here we need to define the type of signalling we're using. Now, we could use one of many different signalling systems, but we want to use British Rail 2003. We need to give our signal mast a name. We start with the bay, and we need to find it on the type of signals that are defined in British Rail. It's a 3-aspect signal, and the signal head is, if you remember earlier, we called it the bay head. So we give it the name of the head, click OK. Now if we close that off, we'll find that we've got our bay head over there is currently dark, and we can change the aspect to danger, back to the heads, and we'll see the bay head has now gone red, which is correct. And we can keep toggling through the various states that are permitted for this signal: caution, proceed. There's also a flashing caution, which is used on some British Railway signalling. We're now going to define the signal for approaching the bay, which is the down approach signal. There's a 3-aspect with a call on, so we pick that from the menu, and see we've now got a choice of 2 heads. The first head is the 3-aspect component, which is the down approach. The second head is the call on light itself. So we define that, and we'll see in the table that we've now got various states. Off is the calling on light, and if we look in the heads, we'll see that the main signal is red and the call on light is gone to lunar. If we change the state, let's say danger or caution, go back to the heads, we'll see that the down head is yellow and the call on has gone dark.